Hello, today we're doing our last part to 6.2. We're going to simplify rational exponents and radical expressions. We are going to do some rationalizing of the denominator, some adding and subtracting. Okay, so let's just go ahead and get started. Now, if you can go ahead and divide. So this problem, pretty easy. I can divide 2 into 250. The reason I'm able to do that is because they have the same root. They're both cubed root. So when I do that, I get the cubed root of 125. I can take the cubed root of 125, and the answer is 5. Now this problem, I can't divide 2 into 3. You cannot leave a root in the denominator. Now usually we just multiply by that same root. The problem is I need 3 of them. So what I do is I say to myself, I have 1, 2. I'm taking the cubed root. How many more 2's do I need? 2, right? What is 2 times 2? 4. So what I'm going to do is I'm going to multiply the numerator and the denominator by the cubed root of 4. When you do that, on the top you get the cubed root of 12, and on the bottom you get the cubed root of 8. We know what the cubed root of 8 is. The cubed root of 8 is 2. So you leave your answer as the cubed root of 12 over 2. You cannot simplify those because one's on the inside and one's on the outside. Okay, let's try another problem like that. All right, I cannot divide 7 into 8 or 8 into 7. Now, 8 is made up of 2 times 2 times 2. I already have 3 2's. You can multiply by 8, but then you're going to have a huge number because you're going to have to multiply by 8 times 8 times 8 times 8, put them together, and you're going to have something so big to simplify. And you probably don't want to do that. So I try to break it down. I know that 8 is 3 2's. I'm taking the 5th root. So how many more 2's do I need? 2. So I'm going to multiply the top and the bottom by the 5th root of 4. Watch what happens when I do that. I have the 5th root of 28 over the 5th root of 32. I can take the 5th root of 32, that's 2. So on the top, I have the 5th root of 28, which I cannot simplify, and on the bottom, I have 2. I know that's a little bit tricky, okay? I want you to try on your own, and I'm going to get you started. If you look at 16, it is made up of a bunch of 2's, but it's made up of 4 2's. So it's easier to look at 16 as 4 and 4. If I have 2 4's and I'm taking the cubed root, how many more 4's do I need? Okay, I'm going to leave that alone and let you guys try that one. We'll talk about it tomorrow in class. Okay, like radicals or radical expressions with the same index and the same radicand. To add or subtract them, use the distributive property. We'll talk about this. Okay, so this one, I have the 4th root of 10 and the 4th root of 10. This one has a coefficient of 1. This one has a coefficient of 7. You're just going to add the coefficients. So I get 8 to the 4th root of 10. I cannot simplify the 4th root of 10, so I leave my answer there. Number 2 has a root w, has a root w. So I can go ahead and add the coefficients. I can add 1/5 plus 3/5. That gives me 4/5 root w. Done. Okay, this one looks messy, but remember, another way to write this is the 5th root of 8. So I don't need to rewrite it. Leave that alone. It's like this problem up here when we had the 4th root of 10. These are like rational exponents. So I just add the coefficients, the 2 plus the 10. So I get 12 times the 8 to the 1/5 power. This is your answer. I know it looks a little messier than you're used to, but that's what we leave it as. Okay, this one has an x and a y to the 1/4, a xy to the 1/4. So again, I'm just going to go ahead and combine my coefficients. 3 minus 8 is -5, and then we leave the like terms alone. Done. Okay, so not so bad. Now, it'll get a little trickier in a problem like this. Right now, I can't add the cubed root of 54 and the cubed root of 2. So what you're going to try to do is simplify it if you can. Let's see if we could simplify 54. I know it's 9 times 6, I know it's 3 times 3, and I know this one's 3 times 2. So I can simplify this because I have 3 3's, so 3 cubed root of 2 minus the cubed root of 2. Now I have like radicals, so now I can go ahead and add combine the coefficients. 3 minus 1 is 2. 2 cubed root of 2. Okay, next problem. These are not like radicals. This one I can simplify a little bit. Okay, what you can do is we can take out 3 z's. If I take out 3 z's, I have 1 on the outside, and I'm left with 2 on the inside. Okay, next problem. I can simplify the cubed root of 54. Now I already did that over here. I know it's going to be 3 cubed root of 2. So I'm going to put a 3 on the outside. So I have 3z, the cubed root of 2z squared. Now I can combine my like terms. 12 minus 3 is 9. 9z cubed root 2z squared. I know that one's a messy one, and we will practice more of those. Okay, now I want you to go ahead and try the u-try. Right now they're not like radicals, so we're going to have to simplify this cubed root of 81. Then we're going to go ahead and add the coefficients. Give that a try on your own. All right, variable expressions. The properties of rational exponents and radicals can be applied. So we talked about when it's odd and when it's even. We can't take the even root of a negative number. It has to be the absolute value. Okay, we'll talk about that in here. All right, now some of these are not so bad. Some are a little bit more challenging. So let's just go ahead and get started. All right, this first one. It's easy to make a giant factor tree. I just like to make a factor tree for 64. Actually, I don't even need to make a factor tree for 64. What number raised to the third power gives me 64? 4. Now, here's how I like to do the the variables. Take 3 and divide it into 6. How many times does 3 go into 6? 2 times. So it's y squared. Okay, let's look over here. This one, we can go ahead and distribute. So I get 27 to the 1/3 power, p to the 1st, and q to the 4th. These are perfect. There's nothing I need to do there. What's the cubed root of 27? 3. So my answer is 3p q to the 4th. So not so bad, right? Okay, next one. Now we're kind of throwing this all in. You need to get rid of the radical in the denominator. Now this one works out a little bit easier because 4 divides into 8. 4 divides into 8 to give you n squared. I don't need to do any multiplying, okay? And then 4 divides into 4 one time. That's it. Pretty easy. Best case scenario. Okay, this problem we're going to go ahead and simplify. 14 divided by 2 is 7. Now we have x to the 1st over x to the 3/4. So you need to subtract. When you subtract 1 minus 3/4, you get 1/4. You put it where the bigger exponent is, which is on top. Now we're going to subtract. Oh no, we only have one y, so we leave y alone. And then the z we leave alone. That's it. Perfect. Okay, now the next one can get a little bit messy. The next one you need to rationalize. Here's what I like to do first. It's just my preference. If I can simplify, I like to simplify. The top I cannot take the cubed root of any of those. The bottom I can. The cubed root of 8 is 2. I cannot take the cubed root of x. And then the cubed root of y is y. 3 divides into 4 one time with 1 left over. Okay, so I need to get rid of this. So I look at it as I have 1x and 1y. How many more do I need? Well, I need 2 more x's and 2 more y's. So this is what I'm going to multiply by. When I do that, on the top, I get cubed root of 3x cubed y squared z. And on bottom, I get 2y, the cubed root of x cubed y cubed. Now, what was the whole point of this? That I can simplify this. So on the bottom, 1x comes out, 1y comes out. I have no radical. On the top, an x comes out, not the 3, not the y squared, and not the z. Now, I can cancel out those x's. So my answer, this is a lot, I know, 3y squared z over 2y squared. So I have y and y. And we will definitely practice more of these, I promise. The u-try is not like that, however. The u-try, let me show you that one and just get you started on that. Okay, the u-try, what I would do is I would go ahead and multiply these together. Take the cube root and multiply everything. So I get 24, x to the 13th, y to the 9th. Now go ahead and simplify. If you have any questions, comments, or concerns, go ahead right at the bottom of the paper, and I'll see you tomorrow in class.